This lecture is on acid-base theories and acid strength. Acids have the following characteristics: 1, sour taste; 2, irritant; 3, corrosive when it reacts with metals; 4, neutralizes bases. Bases have the following characteristics: 1, bitter taste; 2, slippery and feel; 3, caustic; 4, neutralizes acids. Under the Arrhenius theory, Arrhenius acids are proton producers. For example, HCl gas in water produces H+ and Cl- ions in aqueous phase. H+ and HCl+ will interchange because in reality, H+ doesn't really exist in aqueous solution. Arrhenius bases are hydroxide producers. For example, KOH solid in water produces K+ and OH- ions in aqueous phase. Under the Bronsted-Lowry theory, Bronsted-Lowry acids are proton donors. Bronsted-Lowry bases are proton acceptors. Bronsted-Lowry bases must have a lone pair of electrons, but the overall charge can be neutral or have a net negative charge. The first example is HCl plus H2O forming Cl- plus H2O+ ions. Here, HCl is the Bronsted-Lowry acid, and its conjugate base is Cl-. H2O is the Bronsted-Lowry base, and its conjugate acid is H3O+. The second example is H2O plus NH3 forming OH- and NH4+ ions. Here, H2O is the Bronsted-Lowry acid, and its conjugate base is OH-. NH3 is the Bronsted-Lowry base, and its conjugate acid is NH4+. Here are two sample questions. Provide the conjugate base in the following species: 1, HSO4-, 2, H3PO4, 3, HClO4. Provide the conjugate acid in the following species: 1, HC2O4-, 2, CO3-2-, 3, OH-. The answers are as follows. For the question, provide the conjugate base in the following species: 1, SO4-2-, 2, H2PO4-, and 3, ClO4-. For the question, provide the conjugate acid in the following species: 1, H2C2O4, 2, HCl3-, and 3, H2O. Here before you are molecular views of both a strong acid and a weak acid. An example of a strong acid is hydrochloric acid, which ionizes completely in water to form hydrogen or hydronium ion and chloride ion as the conjugate base. An example of a weak acid is acetic acid, where it ionizes partially in water to form some hydrogen or hydronium ions and its conjugate base in acetic ion. But most of the mixture will be in the form of acetic acid, or HC2H3O2. Here is the list of some strong acids, including HCl, HBr, HI, H2SO4, HClO4, and HNO3. Some examples of weak acids include HF, HCN, and HAC. Here are molecular views of both strong and weak base. An example of strong base is sodium hydroxide, where in water it dissociates to form sodium ions and hydroxide ions. An example of a weak base is ammonia, or NH3, where in water produces some ammonium and hydroxide ions, but most of the mixture will be in the molecular form of ammonia. Strong bases include all group 1A hydroxides, including LiOH, NaOH, and KOH. In addition, group 2 hydroxides, including CaOH parentheses 2, SrOH parentheses 2, and BaOH parentheses 2. Some of the many weak bases include NH3, CO3 2-, PO4 3-, and SO3 2-. In summary, strong acids completely dissociate in aqueous media to form its corresponding ions. Weak acids only dissociate slightly into ions, so most of the acid remains mainly neutral in aqueous media. Strong bases completely dissociate in aqueous media to form its corresponding ions. Weak bases only dissociate slightly into ions, so most of the base remains mainly neutral in aqueous media. In an equilibrium system, if the stronger acid and stronger base lie on the reactant side, acids will readily give up the proton to the base, which will accept to form the weaker acid and weaker base. On the product side, and the larger arrow is headed towards the right side. Equilibrium is product favored. An example is HCl plus F minus is going to drive towards the product side, forming HF and Cl minus. The reason is HCl is a stronger acid than HF. Additionally, F minus is a stronger base than Cl minus. In an equilibrium system, if it turns out that the stronger acid and stronger base are formed on the product side from combining the weaker acid and weaker base on the reactant side, then the large arrow is headed towards the left side. Equilibrium is reactant favored. An example is HF plus Br minus is going to unlikely form HBr and F minus. The reason is because HF is not a stronger acid than HBr, and Br minus is not a stronger base than F minus. In summary, strong acids form weak conjugate bases when behaving as a proton donor. Strong bases form weak conjugate acids when behaving as a proton acceptor. Here is a review exercise for you to work on. Look at these three systems. Are the systems product favored or reactant favored? See chart on the right side. 1, HCN plus NH2 minus forms NH3 plus Cn minus. 2, HF plus HS minus forms H2S plus F minus. 3, H2O plus NO3 minus forms OH minus plus HNO3. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing the exercises.